Okay, so this next section is about arcs and chords. Remember, a chord is a segment whose endpoints, both endpoints, are on the circle. And so arcs and chords, there's some theorems that have to do with the relationship between some arcs and some chords. All right, let's go. Okay, so first, this first section, I'll just like read and explain. It says points on a circle determine both chords and arcs. And so what we mean by that is notice like say R and S. R and S can determine this chord. It's the endpoints of the chord. R and S are also the endpoints of this arc RS. So when that happens, when a minor arc and a chord share the same endpoints, that's right here, we say that the arc is the arc of that chord. So we would say that arc RS is the arc of chord RS. And so while there are theorems that have to do with the two of them, they're not the same measure. So that's what I have right here, because the arc is measured in degrees, and the chord is measured in linear units. And yes, we can find the length of an arc, but the length of this arc would definitely not be the length of that segment because this is a curve, so it'd be longer. So the theorems that we're going to learn, just remember that the arcs and the chords do not have the same measure. There are certain relationships that are true. So here's the first one. It says, in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So see in this picture here how RS is congruent to ST is congruent to TU. Those are all chords. So since segment RS is congruent to segment ST and is congruent to segment TU, that would mean that the arcs are congruent. So the arc RS would be congruent to arc ST. Whoops. Would be congruent to arc TU. So you can label them if you want to with congruent symbols as well. So in the directions, it says that the measure of arc RS is 60 degrees. So that means all of them are 60 degrees. So when it says find the measures of arcs ST and TU, that'd be 60 because their corresponding chords are congruent. So if the chords are congruent, the arcs are congruent and vice versa. So if I gave you we had congruent arcs, then you could determine that their chords are congruent. Okay, so that's the first theorem. The next theorem has to do with when you have a diameter or a radius that is perpendicular to a chord, it bisects the chord and its arc. So see right here, this radius is perpendicular to this chord AB. So that means it cuts AB in half, the chord. It also cuts arc AB in half. So that means arc AC would be congruent to arc CB. Okay, let's label the given information. It says that AB is 40. So think about if this whole thing is 40, then that's going to be 20 and that's going to be 20 because the whole thing was 40 and it's cut in half by this radius. Then it says the measure of arc AC is 71. So AC right here is 71. We already determined that that's congruent to CB, so that's also 71. So just like in that last section, I always like to label the picture with everything I know, and then I can go from there. So now we can answer the measure of arc BC. We can see here is we already labeled as 71 degrees. The measure of arc AB, this whole thing, where you would just add 71 and 71 to get 142. I'll put over here, we did 71 plus 71. And then segment AD, we already labeled as 20. And again, that was because it was cut in half. And then BD is also 20 centimeters. Okay, so that's the second theorem about arcs and chords. There's one more theorem that we'll talk about, and then I'll do a few examples for you. Okay, The last theorem for this section says, in a circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So remember, equidistant means the same distance. So if you see in this example right here, see how LU and UM are congruent? That little segment there, LU and UM, those represent the distance from the chord to the center. I don't know if you guys remember, I can't remember what unit it was in, but we talked about how the distance between a segment and a point is the shortest distance, which is a perpendicular piece. So this represents the distance from VW to the center. Now that I made a mess of this, let me erase this. Okay, so since LU is congruent to UM, I'm going to write this. That would make VW, the segment, congruent to ZY. But then we learned on the other page that if these chords are congruent, their arcs are also congruent as well, which we don't need in this particular scenario, but why don't we write it anyway? So, and arc VW is congruent to ZY. So us just knowing that these chords are equidistant to the center gives us all of this information. Okay, so it gave us some information. It said VW is 20, YZ is 5x. So obviously we're just going to set those equal to each other. And so x is 4, super simple. Okay, next one is the same idea, but it just goes in the opposite direction. So that you're given congruent arcs. So then we can determine that these chords are congruent, and then therefore we can determine that SZ and UZ are congruent. So the arcs are congruent, so the chords are congruent, so the distance to the center is congruent. So that means that SZ and UZ are congruent. So we're just going to set those equal to each other, just like in the last one. Okay, so I would subtract x, add 1. So we get x is 5. Okay, so that's that theorem. The next few examples are just kind of examples of like using all the theorems. This example, this first one down here, is an important one. You will see problems like this on your practice. And so problems like this where you're not given a picture, you have to draw a picture to determine what you're given and what you're going to do from there. Now, no matter what, I always draw my picture the same way because all of these problems, the ones where you have to draw the picture, they're all kind of solved in the same way, sort of. You'll see. So I always start with my circle. Oh, look at that. Made it a nice perfect circle for me. And then in each problem like this, you're given a chord, a radius, and the distance from the chord to the center. So how I like to draw it is I always make my chord at the top. Oops. Okay. So I like to make my chord at the top of the circle. Let me try one more time. Okay, so I always put my chord at the top of the circle. Then we need the distance from the chord to the center. So let's say the center's here. This would be the distance from the chord to the center. Remember that the distance from a segment to a point is always perpendicular. So I can add in that that's a right angle here. Okay, and then they always talk about a radius. Now, you're not always given a radius. In this example, you're asked to find the radius, but in the next example, like on your homework, it might tell you you might be given the radius and you're going to find the chord, or you might be given the chord and the radius and you have to find the distance from the center. So each time that you do it, there's something a little bit different that is given and something a little bit different that you're going to find. So you always want to draw in a radius. Now, technically, like a radius could be anywhere, right? But drawing it in those random spots is not going to help you. So I like to draw it here because that's a radius, right? 1 point at the center, 1 point on the circle. And look what it makes. It makes a right triangle. So maybe some of you are already thinking Pythagorean theorem, hopefully. But for all of these problems like this, where you draw the picture, you solve it using Pythagorean theorem. So let's just label the parts that we were given. So it says the chord is 20 inches long. So that's this whole thing is 20. But we learned that since this piece is perpendicular, it cuts it in half. So then each of these pieces are 10, which really we only need that one because that's the one that's in our triangle here. Okay, then it says it's 24 inches from the center. Now, obviously mine is not drawn to scale. Don't worry about that. It doesn't really matter. So that's 24, this distance. And they're asking us to find the radius. So that's your x. So this is Pythagorean theorem. Remember that your c is your hypotenuse, which will always be the radius. So I'm going to set mine up. A squared and b squared are the numbers that I know. And then my c squared is the radius. But sometimes you might be plugging in a number here and your variable will be here. Remember that it's not always, your x is not always your c. Okay, so now we can solve this. So that's 100 plus 576 equals x squared. Add these two together. 676 equals x squared. Take the square root. So x is 26 and it's inches. Okay, so there's one like that. There are 4 that you're going to do for the practice. So just draw a picture. Always set it up just like this. This is the picture, the same exact way as mine, and then label accordingly. That's what makes it easy. Okay, so number 2, we are given that these chords are congruent. So think about that means that these arcs are congruent. So if this one's x, so is this one. So notice that these 3 arcs make the full circle. So you could do 2x plus 70 equals 360. You could also just do this without an equation and just like do the math, because you're going to subtract 70 from both sides and get 2x equals 290. And then you're going to get x is 145. So again, you could have done that without actually writing an equation. Okay, so the last one, we are given that DG is equal to GU. So let's label some things here. DG and GU are equal. So that's it. That means these chords are equidistant. So that would mean the chords are congruent. CA is congruent to TR. And also the arcs. This particular problem doesn't give you anything about the arcs, but the arcs we could also conclude are the same. Think about too, because this diameter is perpendicular to the chords, those are cut in half. So like CD and DA are congruent, TU and UR, and we can even go as far as doing CB and BA and TS and SR. So a lot of pieces are the same here. Okay, I'm going to switch colors. We're given just that 5 and the 3. So letter A is asking us to find TU. So this is kind of like that example that I did where we had to draw the picture, because we have a right triangle here. So always look for right triangles in this section, and that's how you know you're going to do Pythagorean theorem. So there's my x. So in this case, my c is 5. So I'm going to have 3 squared plus x squared equals 5 squared. So it's going to be 9 plus x squared equals 25. Subtract 9. X squared equals 16. Take the square root. X is 4. Do we have a unit? No. Okay, so that means this is 4, this is 4, this is 4, this is 4. All those pieces are 4. So when they're asking for TR, those two together, 4 plus 4 would give us 8. CD is 4. That's another one of those little pieces. And GD we already determined was 3, because at the beginning they told us that those were equal. Okay, so these are just a few examples that you could see with arcs and chords. It's hard to go over like every type of question you might see, but these are the theorems that you're going to use. So any problem that you have on the practice that you're going to do, come back and refer to these theorems. All right, let me know if you have any questions. Have a great day.